And so what the problem is asking us to do is that given k and given n, we got to find n numbers. So these are the 5 numbers, okay, which in base 10 are read the same both front and back, and they also read the same in base k, which is base 2 here. So now this is the problem. So in this problem, one of the challenges figuring out like how do we proceed. We have base 10 numbers, and these numbers don't have any upper limit, and then there are base k numbers, which again they have a different pattern, right? So one of the things that we could do is generate base 10 numbers and check if valid palindrome in base k. Now this is what we will have to do, but we cannot generate all of the numbers. If we generate all of the numbers, we will get into TLE. So we're gonna apply a little bit of a trick, and the trick is gonna help us execute this. So since we want the number to be read the same way in the front and the backward direction, what this means is that as we are generating a number, okay, so we'll have to enumerate and generate a bunch of numbers, right, before we actually validate and then accept that number. So when we're enumerating, what we will have to do is, if the size of this number is d, corresponding to d digits, then we will be filling only d by 2, because we'll be placing the start and the end with one of the numbers in the range 0 to 9, which is equal to 10 digits. Once we have filled this, let's say we have filled 1, 1, okay, then what we have here is a subproblem, okay, where again these two dashes can be filled with numbers from 0 to 9. So what happens is, this way we go on doing a recursion, and in the recursion we are first completing this path before we actually jump to the next iteration, which might be 2 2, okay. And this is okay with us, because when you're doing this, you're picking up numbers in ascending order, and because you're picking up numbers in ascending order, you're actually creating the you're generating the smallest numbers first and validating them first, okay. So only after the smallest numbers are validated, then you're going to the next set of iterations. So this is okay with us. All right. And now we think about, all right, so let's say that we have the consensus that the step 1 maybe is to generate palindromic numbers in base 10, and then step 2 would be to verify if palindromic number in base k, okay. So if we identify a number which is palindromic in base 10 and also palindromic in base k, what we have to do is, we don't have to collect all of the variations. What we have to do is, we have to take the base 10 value of those and just sum them up till we have covered minimum, or let's say smallest n numbers, okay. N is another variable that has been given to us. So this is one of the So this is rather the core step. Okay, but this core step has to go inside another bigger logic that will enumerate, okay, and iterate different number of digits. Okay, so you start with a single digit and then you identify all possibilities, all palindromic in base 10, then you verify in base k. If it is okay, you return the value and you sum it up with the total. Okay, and you repeat this process. Now in this process you have exhausted few numbers from the given n2. So maybe you exhausted let's say m, so you still have to find n minus m numbers. Okay, so what other option you have? You switch to double digit. Now here again you create all possibilities to the same approach. These are palindromic numbers that you created in base 10, validate with base k, and then add to the total. And you do this process till your n is greater than 0. So this becomes the outer or the more logical loop. So this is about the execution of the program. Now what we can do is we can look at the solution. Okay, the solution is going to be a little bit lengthy because there are multiple steps, but I'll try to break it down into conceptual blocks so that it's readable and also understandable for the video. Okay, so let's say we start with our first main method, which is kMirror self. K is an integer value and n is an integer value, and we have to return the total value, which is another integer. Now this function is given to us as part of the Leetcode problem. So let's start from here. Okay, so you can think of it as the main function as the starting point. So this is where we start. So let's say we start with digit equal to 1 and our total right now is equal to 0. So now we say while n is greater than 0, what we do is we compute a digit array which is going to hold my values. So this is of the size of digit. Now I get a subtotal from a recursion and also balance n from, let's say, a recursive function called recurse. And to this, as in my digit array, I also send few other information, which is if my digit array is something like this, let's say 4 dashes, and I've placed 1 at the first, then I need to enumerate values for these two places. So initially my start was equal to 0 and my end was equal to 3. Next I proceed, so my start is equal to 1 and end is equal to 2. So that's how I'm going to keep a track. So starting with start is equal to 0, end is equal to I can just say len of digit, or I can just say digit. Okay, that's the number of digits we have here. Along with that, I will pass n because I got to keep counting how many numbers I have, valid numbers I have seen. I also need k because I need to do the base k conversion. So all of that will happen inside this recursive loop. Finally, we sum up this subtotal with total, and next, if our number hasn't become equal to 0 or lesser than 0, then we are going on the next iteration of digit, one larger digit count. So once all of that is exhausted, I return my total. So this is the first block. Okay, so this is the first block of code that we're looking at. Okay, now let's keep this aside. And now let us look at the recursive function. Okay, which was my def recurse. It's a self function, takes digits, which was my digit array, takes the start value, takes the end value, takes n, takes k. Okay, now let's work out the end cases here. Okay, so let's say I am creating this particular digit. My start is here, end is here. This has been filled up. My start is here, end is here. This has been filled up. And for the next iteration, my start is going to cross over. And so when my start is greater than n, what that means is I have completed one variation of a number which is now available for me to validate. Okay, so let's do that. So that's my end case because I am recursing to generate these numbers. This is the enumeration that is going on. Once that is complete, I have to validate. So if start is greater than n and self is valid, is valid base k digit with k, and I have to select a number, then I can pick up this number. Then let's return it. So return integer of, combine the array into a string and then typecast it to integer, dot join map str of digits. Okay, so you're returning this and you're returning one less count because we have found one valid number, and so we're returning the value of that number. Okay, else I else start is greater than n, which means I did reach the n, I did reach a variation, or I did complete a number, but it was either not valid or the number of picks that I had to take was already exhausted. Then I can't do anything. So let's just return 0 comma n, returning 0 comma n and not 0 comma 0 because there is a chance that this number was not valid, but I still have to pick some numbers. So let's keep it at n. Okay, so my end case is done. Now let's work on the case where I have probably filled some numbers and now I need to fill the others. Okay, so what we say is let's have total is equal to 0 for d in range of 10. So it will pick 0 to 9. What we say is digits of start is equal to digits of n, which is equal to d. Okay, and then I get count comma n equal to self.recurse digits. Same thing, now moving forward, start plus 1, n minus 1, n and k remain the same. Now when I am changing the state in a recursion, when from here I have to take another path, I cannot take the state that was at this point, right? So as I go backtrack, I reset the state, and so I start from the state that was set for this path and then continue forward. So let's do that. Digits of start and digits of n is again back to 0. I have reset it. So now total value increments. This is my count, and let's return outside the for loop, return total comma n. So now this is the recursion piece, okay, where all we are doing is trying to fill two blanks and then recursing further to fill the remaining inner blanks. And while we do that, we also verify once all of the blanks are filled up, we try to check that did we get a valid base k here. If we got, then we must definitely take this value so we can count it. Okay, so now let's get to the next important method, which is valid base k. Okay, so def is valid base k is another self method, and it takes digits and it takes k because it needs to convert these digits to base k. Okay, and so is valid function for me is going to be sort of an wrapper function, which is going to check two things. The first thing is that which was mentioned in the question and I forgot to mention, is that we should not have any leading zeros in the number. So if a digit of 0 is equal to 0, then we return false. Okay, and then we convert base k digits, which is equal to, from another helper function, convert to base k, you take digits and you take k, and now you check if this is a valid palindrome. Self is valid, or let's just say is palindrome. So is my base k digits also a valid palindrome? My base 10 digits or my digits is definitely a valid palindrome because that's how I'm constructing it. Now I'm checking if my base k also happens to be a valid palindrome. If that is the case, then we can safely return true. Otherwise, unfortunately, we have a false case here. Alright, so next, let's work on the base k conversion. Okay, so now we're looking at the function def convert to base k, which takes self, which takes digits, which takes k. Now for this, we need to convert our array back to integers. So let's do that. Alright, so once we do that, now if let me really quickly recap how we compute the base k, right? So let's say I had 4 and I'm converting it to base of 2. Okay, so I take 4 and I take 4 and divide by 2. What I get is 2 and my remainder is 0. I take 2 again and divide it by 2. What I get is 1 and my remainder is 0. And so my binary representation of this is 0, 0, 1, which is read like this. Okay, this 2 to the power 0, which is 1, this 2 to the power 1, which is 2, this 2 to the power 2, which is 4, 1 here. Okay, so that's what we got here. So that's the operation that we're going to be writing here. So this is our remainder, which is this, and we'll say while number is greater than 0, you have remainder dot append. What did I get what remainder did I get when I divided it by k? Okay, so you get number modulus k, And then when you go into the next step, you are dividing it by k. So now number this, which is nothing but writing it as number is equal to number by k. Alright, and then finally we need to read it in the reverse order. So return remainder all of the values in the reverse order. So now we are done with our base k conversion also. Now we are left with a very simple function of is palindrome. Alright, so def is palindrome, again a self method, takes just the digits, okay, and start is equal to 0, end is equal to len of digits minus 1, while start is lesser than end if digits of start is not equal to digits of n. Oops, we realize that it's not a palindrome, so return false. Otherwise, what we do is just move forward, start plus equal to 1 and minus equal to 1, and finally we return true. And this is the code that works and will get passed through the Leetcode system. Let's also think about the time complexity of this problem. I haven't been covering time complexity in my previous problems. I realized that is an important aspect that I should be doing. So if this input is of size equal to d, then we are traversing this till both the pointers meet at the midpoint, and so the time complexity of this is d by 2. So we're just traveling at half the time. When you come to base k conversion, at every step we are dividing number by k. So here the time complexity will be log k of the number which is of the size digit. So let's call it d again. So for every number we are converting it and then also checking the palindrome. So far our complexity would be d plus d. Okay, and then if we look at this is the function that is enumerating and generating all of the possibilities, and for each of those possibilities we are generating the base k and validating the palindrome. But let's see how many times does this function execute. Okay, so for every digit there is a possibility of taking a value of 10. Okay, and we pick one number and we fill only d by 2 blanks. So the time complexity of this should be d by 2. And so the overall time complexity should be, for the numbers that we generated, we are generating the base k values and then verifying it. So this should be a time complexity for a given d. Now, since there is no upper bound to d, it is hard to tell what that would be. So I will just leave it at this. Yes, that's it for this problem. I'll see you again with another problem next time. Thank you.